Do you want to know the simple concepts of dimensional analysis? Hello guys. Welcome to my YouTube channel, Jack's Insights. This channel offers educational and entertaining videos specially made for the interested and curious viewers. Please watch the video till the end. And don't forget to like the video. Leave a comment. And of course, please subscribe to my channel and click the notification bell for the updates. I will be uploading more educational and entertaining videos specially made for you guys. Thank you. Welcome to our dimensional analysis class. I am Sir Jack.
In this video, you will be able to internalize all important concepts related to dimensional analysis and value the concepts of dimensional analysis in dealing or solving problems involving quantities with dimensions. Short history of dimensional analysis. The origins of dimensional analysis have been disputed by historians. The 19th-century mathematician Joseph Fourier is generally credited with having made important contributions based on the idea that physical laws like F equals ma should be independent of the units employed to measure the physical variable. This led to the conclusion that meaningful laws must be homogeneous equations in their various units of measurement, a result which was eventually formalized in the Buckingham Pi theorem. However, the first application of dimensional analysis has been credited to the Italian scholar François David de Fontenay, 1734–99. It was published in 1761, 61 years before the publication of Fourier's work. James Clerk Maxwell also played a major role in establishing modern use of dimensional analysis by distinguishing mass, length, and time as fundamental units, while referring to other units as derived units. This is Joseph Fourier credited for having important contributions to dimensional analysis, especially the Buckingham Pi theorem. This is François David de Fontenay credited for the first application of dimensional analysis. This is James Clerk Maxwell who established the modern use of dimensional analysis. We will start our discussion by defining dimension. What is dimension? It is a physical property which describes a way any physical quantity is related to fundamental physical quantities like length, width, mass, etc. Next, let us define the very focus of this discussion, the definition of dimensional analysis. Dimensional analysis is the analysis of the relationships among different physical quantities by identifying their fundamental dimensions, such as length, mass, time, etc., and tracking these dimensions as calculations or comparisons are performed. It is also a problem-solving method that uses the fact that any number or expression can be multiplied by 1 without changing its value. Physical quantity. Physical quantity is a physical property of a phenomenon, body, or substance that can be quantified by measurement. It can be expressed as the combination of a number and a unit or combination of units. There are two types of physical quantity. First is fundamental physical quantities. These are the quantities which cannot be expressed in terms of any other physical quantity. Second is derived physical quantities. These are quantities whose definitions are based on other physical quantities, fundamental quantities. Unit. Unit is the reference used as the standard measurement of a physical quantity. The units in which the fundamental quantities are measured are called fundamental units, and the units used to measure derived quantities are called derived units. These are quantities whose definitions are based on other physical quantities, fundamental quantities. The International System or SI system is the international system of measurement which being widely used today as the standard measurements. It is the only system of measurement with an official status in nearly every country in the world. It comprises a coherent system of units of measurement starting with 7 base units, which are the second, the unit of time with the symbol S, meter, length, m, kilogram, mass, kg, ampere, electric current, A, Kelvin, thermodynamic temperature, K, mole, amount of substance, mole, and candela, luminous intensity, CD. The system allows for an unlimited number of additional units, called derived units, which can always be represented as products of powers of the base units. 22 derived units have been provided with special names and symbols. The 7 base units and the 22 derived units with special names and symbols may be used in combination to express other derived units, which are adopted to facilitate measurement of diverse quantities. The SI system also provides 20 prefixes to the unit names and unit symbols that may be used when specifying power of 10, that is decimal, multiples and submultiples of SI units. The SI is intended to be an evolving system. Units and prefixes are created and unit definitions are modified through international agreement as the technology of measurement progresses and the precision of measurements improves. The law of dimensional analysis, or called the principle of homogeneity. The equation is dimensionally homogeneous or correct if both sides have the same dimensional units. Only homogeneous or commensurable quantities may be compared, equated, added, or subtracted. However, one may take ratios of incommensurable quantities or quantities with different dimensions, and multiply or divide them. These are the uses of dimension equation. 1. To check the correctness of the physical relation. 2. To recapitulate a forgotten formula. 3. To derive the relationship between different physical quantities. 4. To convert one system of unit to another. 5. To find the dimensions of constant in a given relation. Another important term in the process of dimensional analysis is the conversion factor. It is a ratio which converts one unit of measure into another without changing the quantity. For example, 1 meter is equal to 100 centimeters, so you can determine the conversion factors of this basic relationship, which are 1 meter over 100 centimeters or 100 centimeters over 1 meter. The choice of the conversion factor to be used depends on the condition of the problem to which is the desired unit. Factor label method for converting units. It is the sequential application of conversion factors expressed as fractions and arranged so that any dimensional unit appearing in both the numerator and denominator of any of the fractions can be cancelled out until only the desired set of dimensional units is obtained. For example, convert 27 km per hour to meters per minute by identifying conversion factors. That is, if 1 kilometer equals 1000 meters, and 1 hour equals 60 minutes. Then, the conversion factors are 1 kilometer over 1000 meters, or 1000 meters over 1 kilometer. For the conversion factors of time, we have 1 hour over 60 minutes, or 60 minutes over 1 hour. Then the solution will be 27 kilometers over 1 hour, times 1000 meters over 1 kilometer, times 1 hour over 60 minutes. That is equal to 27,000 meters per 60 minutes, or equal to 450 meters per minute. That's all for this session, class. I hope you get something about the things being discussed. If there's some points which are not clear, feel free to view the video again. Thank you.